That's the best part of class. I'm just waiting for me to set up my camera. So, this is the room that doesn't work, right? Yes. That's okay. Oh, yeah. Why is this? Wait a minute. It's weird. Wait a minute. Everybody just hang out for a second. I gotta unplug and replug things and hope. Alright, let's see. So I'm going to pretend to be on Team Koala, apparently. Alright, for some reason, they're really... Okay, there we go. Okay, so everybody's paper is a little in different order because they didn't want everybody up here at the blocks all at the same time, yeah? But everybody had this problem somewhere. And that's the one that everybody showed me, so I'm not going to go over this. Okay. Same thing with this one. Right, kind of went over this with everybody. So what about, this problem shouldn't have been too big of a deal, right? Expanded form just means to do what? Right, so I have 3 3s and 4 5s. Cool. So can I make 4 15s? Or can I make, so a lot of times I'll get somebody tell me this is 15 to the 7th power. How can you very quickly show them the wrong? Can you make 7 15s from 3 3s and 4 5s? Of course not. So that's a very quick way to show somebody, no. So they kind of multiply the bases and added the powers. You guys with me? Very common mistake to make with exponents. But if you go to expanded form, you can show very quickly that's not true. This guy, I would accept a couple different things, but just straightforward, what do I have 5 up? A, B. So you can do A, B, A, B, A, B, A, B, A, B. And if you did A, and B, 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 that's fine too. Okay. You guys all with me? Okay. This one always trips students out because their brain doesn't realize that powers can only go so far. What's being raised to the 0 power in number 4? What's being raised to the 0 power? X is? And Y is. Cool. Is the 4 having anything done to it? No, it's just multiplying by Y to the 0. So X to the 0 is 1. Y to the 0 is 1, so 1 plus 4 is 5. And in anticipation of this problem, we're always assuming the variable is not 0. Otherwise, this wouldn't be true. Okay, stop for a minute. Some of you guys looking very concerned at me. I think I talked to most groups about this problem. I might not have talked to a couple of you. I can't remember. Anybody I didn't talk to, do you think you figure this out? Did I talk to everybody? Yes.
But I just said that when you have x0, there's an invisible 1, right?
Okay, okay.
So, therefore, it would stay the same. But if you were to have 0, 0, that's 0. That's not 1. Because there's not a 1 in front of 0.
Oh,
Like,
sure there is.
The question
There's a 1 out there. Why not?
But it's 1 times 0. That's 0. It's not 1, right?
But it's still out there.
But there's no variable.
True, true. So here's the problem. I kind of like what you're trying to do. It's not going to quite get you to where you need to be because it doesn't really address this issue. There's a 1 in front of everything, right? There's a 1 times in front of everything. You guys with me? There just is. So how would you explain to yourself why almost anything to the 0 power is 1? So just do that part first, not the almost yet. So one way to do this is to say, okay, if I have an x squared sitting here, this is kind of like what you're saying. So you sort of mix the two together. Isn't there understood 1 in front? All right, if I divide by x, now I have 1 less x, correct? If I divide by x again, if I do the property, I get x to the 0. I have no x's left. So why would I write that? If I have no x's left, what's the only thing left? 1. It's 1 times no x's. And what is 1 times no x's? 1. So one way to look at this is x to the 0 literally means I have no variables. So the only thing I have left is, like you said, the understood 1 in front. How are we doing back there? Man, I feel like all I'm doing is making everybody angry today, but that'll be okay. All right. Another way to do this that I showed some of you guys was to set up a division problem that would lead to x to the 0. Because the only way to lead to x to the 0 is for the powers to be the same. But then you have something divided by itself. And what is something divided by itself? Almost always 1. Okay, so that kind of shows you anything to the 0 power is 1. Except for one thing. And of course, what's the one thing? And I think that's what you're trying to take care of over here. What is 0 to any power, just about? What's 0 squared? 0. What's 0 to the 4th power? So 0 to almost any power is 0, correct? And what did we just say anything to the 0 power is? 1. So 0 to the 0 is somehow 0 and 1 at the same time. Yes, you understand it on this level at least. Do you all agree, therefore, that something weird happens if you try to say 0 to the 0? Does everybody agree that something weird happens? Exactly what is that? I don't know. But I'm just trying to show you that does lead to problems. If you got to calculus, you would analyze the shit out of 0 to the 0. It would mean something a little bit differently. But for us right now, this is worse than undefined. Remember undefined is 1 divided by 0? 0 to the 0 is something called indeterminate. I cannot determine the answer is what that means. It's not even undefined. It's indeterminate. It's worse. So basically, damn it, 0. We invented you. You're giving us a lot of grief. Like, maybe. I love you guys. So again, do you have to know what 0 to the 0 is? No. You just have to understand it would lead to craziness. One way to realize it leads to craziness is it's 0 and 1 at the same time. Is that what it is? No. I can't determine what it is. But it seems to try to be both at once, so I know it's weird. So we just sort of avoid it. We don't think about it. Okay, maybe we stop. And you're not used to this, are you? You're not used to a problem like directly not having an answer. It's easy to raise something to the 0 power. It's easy to raise 0 to any power. But it's incredibly difficult to raise 0 to the 0 power. That doesn't seem right, maybe. I don't know. Okay, I'll stop. What about this one? What do you guys think? I saw one group's approach to this, which is beautiful. You could do a counterexample. So it does not hold for not equals to. Does anyone have a counterexample? Or how did you guys show it doesn't hold? Yes?
A is less than B and B is less than C. Also A is less than C.
That seems to say, all right, if I would have said doesn't hold for less than, then you would show that it holds for less than. I'm saying specifically, does it hold for not equal to? So let me ask you this. If A is not equal to B, and B is not equal to C, is A necessarily not equal to C? Can you come up with a counterexample? The counterexample would mean what? What would have to be true about A and C to be a counterexample? A and C would have to equal each other. So pick a number for A and C. I don't know, 4. 4 doesn't equal 3. And 3 doesn't equal 4. But 4 equals 4, yes? Do you guys see that? Okay. So again, it's not like a standard problem. That's not like a family of problems look like this. It's just an idea, and we did something weird with it. Right? The idea of transitive property. It holds for equality. It holds for inequalities. Does it hold for not equals to? Nope, it don't. Poor little dude. Okay. All right. So can everybody please gather up your blocks and such and put them in the appropriate places up here? I'll help this out a little bit. Thank you. I like this. You guys can stay in your groups if you want to. That's beautiful. Little tears. Okay.
Are we staying in our groups or going up to the desk?
What's up to you? Alright, so we're about to get into a section that I've referenced before. This is the, I'm about to say a phrase that's probably going to make you feel the same as if I said word problems. We're getting to the mental math section. No, I don't want you to go away. Stop it. Yeah, gummit. Thank you. I want this here. Okay. Slowly learning new technology. Okay. So let me ask you guys a couple questions. Let's see what you already kind of know. We've done something like this before. So, how would you do 18 plus 61 plus 12? If you had to do this by hand. In your head, even worse.
73 and plus 10 plus 8.
Okay. So you can do 61 plus 12 is 73, and then you can break 18 up into 10 and 8. Okay.
18 plus 12.
You could do 18 plus 12, because that's using associativity, commutativity. Why 18 and 12? They're compatible numbers. Kick ass. I think I said that before. I love it. So 18 and 12 make 30, plus 61 is 91. The approach you were taking about breaking the numbers down, that's an excellent approach to do also. But obviously if I'm adding or subtracting a bunch of numbers, I'm looking for numbers that go together. And because math people were very creative, we said, let's call them compatible. So, what's it go together? What about, let me see what you guys think about this here. What if you had to do 47 times 18 minus 47 times 8? In your head. In your head. Zombie. Sorry. Why, Jeff? What the shit's your problem, man? What's nice about this? What's the same? Do you see how I can undo a distribution somebody might have done? Do you see how I can take a 47 and kind of like back out? So what did somebody distribute 47 to? 18 minus, no, I took a 47 out. So you see 47 times 18? Yes? If I distribute, don't I get 47 times 18? What must have been here then to get this piece? 8. Let me stop for a minute. Maybe not a minute. We all know distribution. The great thing about math, and you can be as jealous as you want to, is it goes both ways. If I can bring a 47 in, I can take a 47 back out. How does that help me? Why is that an easier problem now? What's 18 minus 8? 10. Freaking 10. And the next easiest number past 1 to multiply by is 10. Because all I have to do is do 1. Add freaking 0. Or more generally, move the decimal over once, right? Okay, you guys know what happened?
Okay, so I don't understand like if you cancel the 47s. Because isn't it 47 times 18 minus 47?
Totally.
Question, or did I read it wrong?
That's the question. Yeah, let me write it again because that's horribly
And
written.
then, yeah, but then there's only 147, so where'd the other one go?
What do you mean? Sorry. No.
In,
I'll tell you this, you ready? What I just wrote only has 147 in it. It was 147 that somebody distributed. So Hiller, help me out. Help me remember. What is 3 times x minus y? How did you just make 2 3s? Did it have a 1? How is there suddenly 2 3s? Do you see how that's a silly question? You're like, no, there's 1 3, Jeff, that I distributed, yes?
okay.
So if I do this backwards and take a 3 out, I'm left with the other part, yes? So if I go back to this, they both have a 47. So what I can think to myself, this isn't necessarily true, and who gives a shit? We made up all of mathematics, so why not? Somebody distributed a 47 to 2 numbers. So let me take the damn thing out, and what did they distribute 47 to? And you can literally cover the 47, 18, minus 8. You see that? You can undistribute. And again, how does that help me? I do this all the time, because I'm a weird-ass math dude. And I have all these little tricks in my head, because I know this shit. So I can estimate really good, or I can just do this and figure out what it is really quickly, and students go, ooh, ah, and I'm like, it's nothing, it's just this. Yes?
Is that the same as like you're gonna take the 47 and since it's positive, subtract it from the other 47 so it cancels out?
No,
Okay.
because I can't subtract before I multiply.
Okay.
So I'm not subtracting anything at first. I am just taking, do you all agree that 47 times 18 minus 8 is 47 times 18 minus 47 times 8? Yes? So I just went backwards. Where would this have come from? This would have come from a 47 in front of an 18 minus 8. But 18 minus 8 is easy. It's 10. And then 10 times 47 is easy. 470. So this is a method you could use to subtract ugly things if they both have the same kind of number involved. Here, let me make things worse by giving you a harder example. This is the thing I do all the time. What is 8 minus 2/3 times 8? Really, Jeff? Fractions? You jackass? But look what this says. That second thing is 2/3 of an 8. Do you guys agree with me? What's that first thing? How much of an 8 is the first thing? 1. It's a whole freaking 8. What's one whole thing minus 2/3 of a thing? Yes, this is 1/3 of an 8, which is 8/3. It's the same kind of idea. 1 whole 8 minus 2/3 of an 8 is 8 times 1 minus 2/3 is 1/3 of an 8. Okay, I might have pushed it a little bit with fractions. But just to show you another example, that was a little worse. I told you it's going to be a little worse. But it's the same kind of idea. If I have a repeated number in an addition or subtraction problem, I can take that out. And at the very least, what am I left with? Smaller numbers. Yes? And then maybe I can kind of put them together. It makes it an easier problem in general. Okay. I like it. So this is using distributivity to help me do an actual just computation problem. No variables, just numbers. Okay. You guys are liking this as much as I thought you might. But here, you guys try this. You ready? You guys try this. What do you got, Jeff? 237 times 37 minus, what is it, Jeff? Let's do 27 times 237. I just wanted to, I suddenly had a thing for 7, so let's deal with it. It's like somebody doesn't know how phone numbers work. What's your phone number? Yeah, that's what it is. So obviously I did the 7s a little bit on purpose, but I mean, what number is repeated? 3. What's the matter? Sorry. So what can you take out? Like undistribute. 237, you can take that out. What would have been in here to make this? 37. You see if I distribute it, don't I get back to here? So what I'm doing, I am not changing the problem. I'm making it look better. Problem's gross to begin with. I don't want to do 237 times 37 in my head. Damn you, Jeff. You don't have to. What has to be here, so that when I do this, I get 27 times 237. 27. And of course you get the same kind of thing happen, yes? Because what's 37 minus 27? 10. And what's 237 times 10? 2370. Don't even have to think. Just throw a 0 on it, yes? What's that? Okay. Probably, what the hell did you write? Understand. You got it? Okay.
So where does the 237 come in?
Where's what? Sorry?
Because you got 237 times 37 minus 27, you just added parentheses
Sure.
in between that. And then what about that extra 237?
There isn't an extra 237. How do you do this? Isn't this times this? Distribute. Yes? Bam. And what's 237 times 27? Bam.
Oh,
Yes?
Okay, I got it.
So from the beginning, there weren't two 237s. That's what I always say to my students. They say, how many 237s do you see? And you say 2. And I'm like, I don't see one. There's one that somebody distributed. Maybe. Look, guys, you're all like, whatever, math boy. Okay. You're weird ass math, yes.
Does it matter the placement, like how it goes on the outside? Is that how you know?
No. In fact, the one we did a second ago, I had it both on the same side, if I remember correctly. Where is it? Yeah, down there. See how the 47s were both here?
So
All that matters is it's the same number in each term. Yeah. So I kind of wanted to make one that wasn't that way to show you that it doesn't matter. Okay. All right. So here, let's get into the. Oh, there's one little thing I want to show you. There's a little side note. I can distribute multiplication over addition. Correct? We just did it. So 5 times x plus 2. What would that be? 5x plus 10. I like it. Said with a beautifully exasperated tone. Does that work for division? Does this work for division? Hell no. Not this way. No. In fact, here, let's do a very direct problem. What is 10 divided by 4 plus 6? What is that? Just, what is that? 1. Yeah, it's 10 divided by 10, correct? I don't blame you. You're like, I don't know what to say right now, man. You tricky. I'm sorry, I don't mean to be tricky. Does everybody agree that's 1? If I try to distribute, what do I get? 10 divided by 4 plus 10 divided by 6. That is not 1. So, distributivity does not work for division. Not this way, but it does work another way. So what if I had this instead? What if I had, you can do it, Jeff. 8 plus 4 divided by 2. If I have it on the right side, it will distribute. And I'll show it to you in a different way in a second, but let's see. What is 8 plus 4 divided by 2? 8 plus 4 is 12 divided by 2 is 6. So whatever I do, better come out to be 6. Or you can throw it all out. So what is, if I distribute 8 divided by 2 plus 4 divided by 2? What's 8 divided by 2? 4. 2. 4 divided by 2, I still get 6. So why does this work? So here's something I desperately need you guys to know. If I have 10 over 4 plus 6, this is not 10 over 4 plus 10 over 6. I'm pretty sure you guys are cool with that fact. You cannot break it up like that. And that goes to this exact problem, yes? 10 divided by 2 terms cannot be broken up. And this poor little 4 had to write that. But if I have 10 plus 4 divided by 7, I can break that up if I wanted to, and that will work. That's the same thing. So as long as the bottom is one term, that's why if I write it, and of course I picked a bad example, nitpick some better numbers. 14 plus 21 divided by 7 is the same thing as 14 divided by 7 plus 21 divided by 7. You guys cool with that? You've done that kind of thing before with fractions. If the bottom is one term, I can break a fraction up. But I don't have to look at it as a fraction. It's just, I'm going to do the same problem again, but write it like this, 14 plus 21 divided by 7. Then it's distribution, yes? 14 divided by 7, 21 divided by 7. What is 14 plus 21? What's 14 plus 21? 35 divided by 7? 5. What's 14 divided by 7? What's 21 divided by 7? So I still get 5, okay. So that works, yes.
Does it have to be on the right side?
It has to be on the right side because then the bottom would be one term. If it was on the other side, the bottom would be two terms. You see that? That's the trick. That's why distribution for division only works if the thing is on the right side, if the single term is on the right side. So it's what the book calls right side distributivity of division. Ugh. Okay, I don't know what happened today. Everybody looks bad. I'm gonna keep going. I don't know what to do with you guys. Okay, so we just talked about this idea. Let's talk about it a little bit more in depth. Compatible numbers. So obviously, again, if I saw 12 plus who cares plus 18, I'd do 12 plus 18 first, right? So addition's pretty easy. Things that go together are things that make whole numbers. Normally I try to look for 10, 100, maybe if I can, or just any whole number, right? So if I had a really silly example like 4 plus 8 plus 5 plus 2 plus 6 plus 5. I could do 10 plus 10 plus 10 is 30. So if I find my 10, so it's that I just use the idea of compatible numbers. Let me stop for a minute. Not necessarily ground shaking. I'm sure you guys have done similar things somewhere. But what about with multiplication? What can somebody think of what might be two numbers that when multiplied would be compatible numbers?
5, 6.
Okay, 5 times 6, that could be.
Anything times 1?
Yeah, 1 is like the number he gets along with everybody. He's like, I'm with you, man. So what about if I had something like 4 times 173 times 25? What happened? Sorry.
No, just made a face. 173.
Oh, okay. I thought you might. That's one reason why I did it.
25 and 4.
So I don't blame you, but why does that not matter that it's 173? Who gives a shit that it's 173? Because what's the compatible numbers?
4 and 25.
Yeah, because what's 4 times 25?
100.
Yeah, 4 quarters is 100. And what's anything times 100? I just add 2 zeros. I don't even care what the number is. You guys with me? So the idea of compatible numbers is the same idea, but with different operations, obviously. What's compatible with different? I like it. You would, Jeff. Now here's one of my favorite ideas. Do any of you guys have a job?
Yes.
Oh shit, okay, that's how you afford things, I see. What's the technical term for if you get paid? I don't know if I'm gonna get this from you. It starts with a C. Sounds like water on your window, but it's not. Compensation, yes, right? So compensation, and it's not like compensating for something. You see older men sometimes compensating, but compensation in this case is like when you get paid. So compensation is when somebody with money gives you some of their money. You with me? So compensation in math would be, let me write this down. Compensation, let me spell. Would be something like, What do you got, Jeff? Let's do 97 plus 59. If you had to do that in your head, it's not horrible, but it's not the greatest thing in the world either. But what's 97 almost? And 100 kicks ass when I'm adding. So I'm going to have this guy compensate him. It's going to give him some of his money. So I can write that it says 97 plus, and of course, what am I going to take from 59? I'm going to take 3. And so what's left in the 59? 56. Good. So it's just like the real world. They give me some of their money. They have a little less. I have a little more. Okay. I like it. Of course, they're just making money all the time. So who cares? And then, of course, I get 100 plus 56. So I get 156. Jeff, you can do it like. So that's the idea of compensation. I can take some from one part and give it to another part. And again, you see how that's kind of related to compatible numbers. 97 and 3 are compatible because they become round when you put them together. Let me stop for a minute. Okay. And I know, I find this stuff fascinating. I understand if you don't quite, but let me see if you guys are... We're going to get to something that I think you might agree with me about. What about if I got multiplication? What if I have something like 88 times 5? Let's make it even worse now. No, let's make it worse. 888 times 5. Okay. I'm multiplying. Can anyone see a factor I could steal from 888 that'll make 5 become stupid nice for multiplying? What's the best number to multiply by besides 1? 10. What factors does 5 need to become 10? 2. So if I take a factor of 2 from him, how do I rewrite him? Break him up. What times 2 is 888? 444 times 2 times 5 is 444 times 10 is just 4440. Okay. Alright, sounds like we all have to study, but we'll do it now. So this idea of compensation, I think it's really nifty, but you just have to understand it. Okay. Oh, here's one of the coolest things. You guys are not going to agree with me. That's okay. Maybe you will. What is the worst number, for example, to have to subtract from if you have to do it by hand? Can you guys put yourself back into that stuff? You're like, it's been a while since I did it. Yeah, it has a bunch of zeros, correct? So what if I had to do 1,000 minus 719? This is what you have to do a lot of. Mario. So what's the best number to subtract from is like 999. Everybody with me? So I think I've talked about this a little bit before. Subtraction is how far apart two things are. So if I make one of the two parts a little smaller and make the other part equally smaller, it's still the same freaking answer. They're still the same distance apart. Say again? No, not that. I see what you're doing, but all I have to do is take away 1. So it'd be 999 minus 7.
60.
Too much.
Oh,
18. Do you guys agree they're both the same distance apart? If you're at 1,000 meters and I'm at 719, and you take one step back and I take one step back, aren't we the same distance apart? So the answer to this is the same as the answer to that. I haven't changed the problem, I just changed what it looked like. And why is this so much better? Why is this one so much better? I don't have to worry about bar. The top is as big as it could be. Ain't nothing you can put on the bottom that's going to bother me, right? 9 minus 7. You can do it from this way. You don't care. 9 minus 1. 9 minus 8. Okay. So here's the ultimate shortcut. Let me see if you guys can listen. No, I'll hold on by that. It makes more sense with decimals, so I'll wait for that. Okay. Now, kind of like what you were thinking, what do you guys remember? The other way to do this method is, what if I had, what's a good example? Yeah, okay. What if I had to do 163 minus 59? That kind of sucks, yes? The top has no zeros, but the bottom is bigger than part of it. So what were you saying earlier? I can sort of do the opposite. So what do I wish this number was? 6. 60. So if I make this go up by 1, I better make this go, no, kind of set you up for that. Also up by 1, so the distance stays the same. This method, believe it or not, is called equal additions. So if I add 1 to 1, I better add 1 to the other one. So there's still, I really want this to make sense. They are still the same distance apart, which is what subtraction is trying to get. So if I keep the distance the same, the answer stays the same. And 164 minus 60. Freaking 104, that's sweet.
What did you say it was called?
Say again?
What does that say? Equal?
Believe it or not, you're not going to believe this. Let me see if this does what the other person's did. No, mine's not as good. Equal additions.
I see it.
Good. It's like start strong and weak. Additions. Okay, maybe. Has anybody ever heard that before? Here, I'll do this. It's a little early for this, and apparently I don't care. If I had to do 1.000 minus 0.342, how excited are you for this? Not. Here's the way to do this. What makes this number 9? 6. What makes this number 9?
5.
What makes this number 10? Done. That's related to the equal additions then. So if you make this 999 and you make this 341, instead of doing that, I can actually just kind of shortcut it. If I make this 9 and I make this 9 and I make this 10, the 10 would carry over and make it become back to 1.000. So again, that's a little shortcut. It's not even something that's in the book. It's just a neat little thing. I have a lot of classes where we do 1 minus something. It's just like a standard thing we do a lot of. So then I show them, like, look at this thing. It's kicks ass. I'm like, we have totally, I don't care.
And you said it was the last one is what makes it 10, right?
Yes,
The other
and that's what makes it all work. Because I make it 9999 and then the last one's 10, then that's why the 1 carries over and that's why it becomes 1 again at the end if I add them back together. So what would, what's 1.00000 minus 0.91346? These are all zeros, by the way. Good. What makes this 9 is 0.
6, 5, 4.
Done. Yay. Okay. And you can double check on the calculator if you want to. Okay. That one's kind of cool. Maybe you agree with me? Is that the one that's like the bare sliver interesting? Okay. Sorry. This is not the most interesting section of the book. I understand that. But these things are important. These are, in fact, we're going to get to a point where we're going to learn some stuff that I'm very curious if any of you feel like you've never learned it, in which case you should be a little angry. We're going to learn stuff like, I can't remember if I talked to you about this yet. How do I tell if a number is divisible by 3? Is there a way for me to know ahead of time if it's divisible by 3? Yes. 4. Yes. 5. Of course. You already know the rule for 5. For a number to be divisible by 5, what must be true? Has to end in a 0 or 5. Did you know there's a rule for 2, 3, 4, 6, 8, 9? There's a rule for 7 that's exceptionally weird. 7's a weird number. Poor little dude. So we're going to talk about all those later. Okay. Blah, blah, blah. Where am I at? Oh, okay. Let's talk about, yeah, okay. Something that's really kind of funky. That was interesting. Oh, neat. Oh, is it doing the thing? Oh, it's doing the thing. Wait. I don't know why it's doing the thing. All right, let's just all watch for a second. Sorry, this fascinates me. I have no idea what I hit. I got to figure this out. So it's
like
redoing everything.
It's like an overview or a replay.
And I was kind of like, all right, just give it a second. Look at what I did. Oh, this is a while back. Oh shit. I'm sorry. I have no idea how to stop it.
Oh, it's at the top.
I think it's the, yeah,
Where is it?
like right to the right of the welcome to notes thing. It looks like a
The
play
YouTube.
button. I think that might be it.
Oh, this little dude here?
It's literally the. I think it's
Yeah, I see him, but I'm doing it, but it's not doing anything.
You just want to get into Well, okay, I didn't mean that in a mean way, I'm just saying.
No, that's pretty gross. Get out of this. Is something down?
Actually, we gotta add it.
I like it. Yeah, if I could figure out what it did. No.
Just swipe out of it and exit out.
More than what did. Alright, let's see.
Oh, wow.
Didn't like any of that.
Is that ChatGPT?
What have I done? I made it angry. Alright.
Looks like let it play.
Alright, I'm gonna let it, it's all just catching up. Alright. So what we're about to get into, we got a couple of things to finish up with mental math, and then we're gonna get into estimation. I'll just talk to you while this thing does its thing. Let me ask you this. If I say estimation, what do you guys think of? What an estimate. Kind of like a guesstimate, yes? Any of you ever done, well, nowadays, let me ask you this. Anybody ever been a waitress or a waiter? No? You've done time, okay. Did you work somewhere where like the receipt actually said the levels of tip? Okay, so nowadays, almost every receipt says.
I don't understand.
Don't kill any of us.
Okay.
I tried. It won't. I tried to turn it off, and it won't turn off. It's catching up. Just please forgive me. That sounded like it was gonna kill us. Yes, this is fashion. Yes, so you guys can relive this like again. Oh look, we're almost caught up. So real quick, guys. Back in the day, before the receipts, all I had the tip levels. Yes. Let that do its thing. Oh, is it a catch up? No. All right. Sorry. Thanks for answering my question. Almost here. Before the days when they had the receipt levels, you would have people that could say, "Oh, I don't know if I left enough tip. I'm not good at math," and they would leave like $1.27 on the $80 meal. And you're like, it should be obvious it's not right. So, there I am. Okay. Am I back? Oh, there. Okay, I'm almost there. That's right. Now it's got to still catch up. So there's a way to what's a good tip? What's your standard tip? 15% is your standard tip, right? Well, there's where she said her thing. She said, "Okay, I won't kill any of you." Okay. It's not here. Okay. If I want to do real quick, guys, do you know how to do 10% of something? Do you know how to do 10% of something? 10% of 100 is 10. So 10% is 1/10 of something. Yes. So here's the neat thing. If I want to do 15% of something, let's say 10% of 60. What's 10% of 60? Because 1/10 of 60 is 6. So what's 5% of 60? Wouldn't that be half of 10%? So 10% of 60 is 6. 5% of 60 must be 3. So then 50% of 60 would be 9. There it is. Good. So like if you had a $60 meal and the service was okay, you can leave $9 tip, right? Now if anybody's ever been a waiter or waitress, you're like, if it's good service, you should leave about 20% maybe. We're back. So you have ways to estimate percentages. And what used to be a really good example back in the day was waiters and waitresses. Nowadays, you guys finally are getting, at the very least, people can't have the excuse they don't know math. Because it's all in the frickin' receipt. And then they can say, "I don't read good." You're like, "No, get out. Just give me your wallet." Because, anyway. Left to right methods. So what this means is something like 431 plus 517. You can see where this kind of method breaks down. So if I want to go left to right, I would go 400 plus 500 plus 30 plus 10 plus 1 plus 7. That's the left to right method. You guys kind of with me? Nothing amazing at all. But what do you get? 947, 11. So that's the left to right method. Nothing incredible there. Where it gets a little bit tricky is if you have something that normally would require you to carry a number. So let's try a different example. Let me try to not press anything except what I want to. Okay, so what if I had to do 376 plus 635? So if we do left to right method, it would be 300 plus 600 plus 70 plus 30 plus 6 plus 5, yes? So I get 900 plus 100 plus 11. So I get 1011. So you notice, that's trying to be an 11 back there. Poor little dude. Okay, you're not going to do it. That's okay. Everybody's going to do it. Okay. What was I about to say? If you'll notice, this is a way to get around not having to carry stuff. But obviously, this is not a great way to kind of go forward. But this is a good little location to be before you teach them how to carry the one, or why you have to, right? Okay. Blah, 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 blah. Oh, and we already talked about this a little bit, but powers of 10. Let me ask you this question. What is 14 million times 2,000? What's the quick way to do that problem besides plugging your calculator? Yeah, 14 times 2 is 28. And then how many zeros? 3, 6, 9. Yeah. Okay, so that's nice. Powers of 10. Multiplying numbers that have a bunch of 10s in them is easy as hell. You just have to count the zeros and make sure they're all represented. Not a major deal. Okay, I think most of us know this. Okay. Because later we'll talk about decimals and how they work with that, but it's just moving the decimal place. So, last thing I want to talk about today. I apologize. Today's been a little bit of a shit show, but I'll be all right. Special factors. Special factors. I'm taking up most of the room, Jeff. So, like, for example, if I do, what's a good example? Here we go. 48 times 25. This is sort of like what we weren't talking about earlier. What can I do to do this? So we're going to incorporate a couple things we've done. So special factors would be 25 as a special factor because it's going to go together with 4, with 8. It's going to go together with those kind of things to make nice whole numbers. So what can I steal from 48? A 4. So I can make it 12 times 4 times 25. What's that? Sorry. Okay. So if I had 48 times 25, I could use the idea of compensation. 12 times 100, and I get 1,200. Something else that's a special factor in a different way that we haven't talked about yet. 99, believe it or not. So if I had to do 34 times 99, that seems horrendous. But if you think about it, what does that really mean? That means I have 99 34s, correct? What would have been much better is if I would have had 100. So I can say, okay, this is 100 34s minus 134. Do you guys see what I'm saying? So 99 is a special factor since it's really close to 100. It's just one less of the things. So what's 100 times 34? Holy shit. And what do you get when you subtract 34? I like it. Okay, so 99 is considered to be a special factor. 5 is considered to be a special factor because it just needs a 2 to make it 10. Here's the absolute last thing. 5 is also special because if I divide by 5, does anyone know the quick way to divide by 5? If I multiply by 2, it makes 10, and division by 10 is easy. Yes? How do I divide by 10? Just move the decimal over 1. So if I was more careful, I wouldn't get a decimal, but we'll be okay. If I multiply top and bottom by 2, what do I get? 38 times 2 is 76 over 10, which is 7.6. So if they have to divide by 5, double it and then move the decimal back one place. That's a shortcut for division by 5. So next time, we'll get into estimation. We'll finish up section 4.1. First thing next time is the quiz, 3.1.3.2. And next time we'll see how much better Jeff is with an iPad. And Siri will continue to not kill us.
I was correct. Something on this, I don't know if you didn't see it or if I just didn't get it back or.
I guess my grade didn't change, I don't think.
Oh, okay.
So,
Sorry.